Having looked at variation in g with altitude, in this video we will look at how the value of g varies with the depth. So let us say we have this as the earth, right? And let us say this is the surface of the earth, right? And let us say there is an object which is at a depth h, right? So this is, say, let us depth h, and the object of mass m is over here. So it is inside the surface because we want to find out how g varies with the depth. So it is at a depth h from the surface of the earth, right? So if I draw another sphere inside this with keeping the center of this earth same, right? Now the most important change that happens is, as far as this object is concerned, which is at a depth h, the gravitational force or the effective mass which is responsible for the gravitational force is this mass. The mass which is outside is not applying a gravitational force on this. So the change that happens is when the object is on the surface of the earth, the total mass of the earth applies the gravitational force onto this mass. Whereas if it is at a depth h, the mass decreases, the effective mass which is applying gravitational force decreases, it is only this mass. So we'll have to find out this particular mass. Okay, so let's move ahead. Let us say this object is at depth h, right? So this particular distance, right? This distance, if I show this distance, right? This distance would be re minus h, because the radius of the earth, which is this distance, radius of the earth is re. So the distance between the center of the earth, right? The center of the, now for this the mass is changing. So when I'm using the word center of the earth, it is this, of course, for this particular sphere, right? So for this particular object, the distance is re minus h, and let me find out the mass of this object. We know that mass of any object is given by volume into density. So if I take rho as the density of the earth, the mean density of the earth, the volume of this particular sphere would be 4 upon 3 pi. The radius of this radius is re minus h, so re minus h whole cube into density, and I'll call this m dash because this is this. And mass of the earth, if I take as v into rho, will be 4 upon 3 pi re cube into density. So this would be the total mass which is applicable to an object which is on the surface, right? So these are the two masses that we have. Okay, now if we look at mg is equal to g me m upon re square. This is the equation for this object when it is on the surface of the earth, right? And when it is at a depth h, mg dash is equal to g. Now mass of the earth is changing. Mass of the earth is changing. Now it is not me over here, but we will have m dash into m upon re, right? Now re is also changing because this would be re minus h whole square. Okay? So I hope you are with me. This here we have found out the masses, the different masses that are applicable. Now we are going back to this equation, right? Mg for when it is on the surface of the earth, this is when it is at the depth h, right? And if I take the ratio of these equations, if I find out again, try to find out g dash upon g in this case. If I take g dash upon g in this case, right, I'll get over here g dash, so I'll get g m dash m upon re minus h whole square, and for g I'll get g m e m upon re square, okay? And if I simplify this, what will get cancelled? G would get cancelled, mm would get cancelled, so I will have m dash upon re minus h whole square into re square upon mass of the earth, right? Now I'll further solve this equation. I know m dash, right, and I know me, this is the mass of the earth, right, when it is on the surface of the object. So I know m dash would be equal to 4 upon 3 pi re minus h cube. The equation is, or the solution is becoming more mathematical in nature. Please stay with me. Re square upon me. Me is 4 upon 3 pi re cube into rho. So if I solve this equation, what do I get? 4 upon 3 pi r cube, 4 upon 3, this would get cancelled, density would get cancelled. This re minus h cube, this is re minus h, so this would give me re minus h, right? re square, so I'll get re over here, and this is the equation that I get. G dash upon g is equal to Re minus H upon Re. So now if I analyze this particular equation, what I can write down is G dash upon G is equal to 1 minus H upon Re. Right? Another way of looking at it. And we can very clearly see over here that if H increases, we'll get a smaller number over here, and a smaller number will get multiplied by G, and G dash would decrease. Right? Let me repeat what I say. As H increases, right, you will be subtracting a bigger number from H, so you'll get a smaller number gets multiplied by G, and therefore G would decrease. And so it's very clearly evident from this particular equation that as we go deeper inside the earth, the value of G would decrease, right? And if we go to the center of the earth, right, then what will happen is that the value of G would become 0, right? If we go into the depth of the earth, right, here what would happen is that the mass that would come into play would be 0, right? So there's no mass to apply gravitational force on it. That's one way of looking at it. The value of G would become 0. And as we go below the surface of the earth, the acceleration due to gravity goes on decreasing and becomes 0 at the center of the earth, where H is equal to Re, right? So for example, if I take H as Re, then I would get G dash upon G is equal to 1 minus 1, which is equal to 0, which would give me G dash is equal to 0, because I know G is not 0. Okay, with this we have looked at variation in G with both altitude and depth, right? Stay with me, look at all the videos as you go along one by one, so that there's continuity, right? Just to summarize this video again and to compare it with variation in G with depth. When we look at variation in altitude, variation in G with altitude, the only thing that was changing was altitude. Right? There's no change in the mass because the object was going out of the surface of the earth. So the mass, effective mass which is there was remaining same. But when we go into the depth, both the things changes. The H also changes and the mass also changes. And therefore we first find out M and M dash, and then get this equation back again. And finally we arrive at this equation, which very clearly indicates that as we go deep inside the earth, the value of G decreases. Thank you.